Give me 1 second, please, to like set up the screen. Just 1 second. All right, here we are. So, well, hello, everyone. I want you to imagine that you're a researcher for the next 3 minutes, okay? You're a researcher in biomedicine. So what's the thing that a researcher needs? A researcher needs to know, among many other things, what's out there. What's the things that other researchers are doing. And this is what we've built for them. So I'm going to show you the platform that we've built. It's an AI-powered platform to analyze the clinical trials ecosystem regarding a certain disease. So for example, here I have a text box where I write the description of a disease, right? And I click Analyze. So what's going to happen here? First, we take the embedding of the text that we just gave, and we are going to look up on a database what are the diseases that are most related to my text. But this doesn't end here, right? Like what we do then is that we have a model which is based on a knowledge graph, which is a set of nodes. You can imagine like a network of all of the diseases that you can think of, 43,000 more or less. And we trained a model that can generate embeddings of those diseases. There's no text here. There's literally just topology. So this is not vulnerable to hallucinations or those things. It's much more solid. And we use it to focus our search on a certain space of diseases that are more closely related. So I searched with some text, but maybe I will get one disease that is about something and some diseases that are not so related to that thing. So what I'm trying to do here is I'm trying to focus on diseases that are similar. So for example, Alzheimer's, memory problems, etc., etc. There's a set of diseases that are close together. And then what we do is we expand the search a little bit. We take the embeddings with the model that we trained. We expand the search to 10 diseases here. You see, we have a correlation matrix. So all of these diseases are related among themselves. And then what we do is we take the labels of those diseases and we embed that thing again. I know I'm saying embeddings all the time. Those are different embeddings. Now we are talking about text. So we take the embeddings and what we do is we search on a database the clinical trials that are about the diseases that we are interested in. So if we go down, we'll see that we are getting the details of a certain set of clinical trials. And here we have 19, for example, 19 clinical trials that we will summarize using prompt engineering to get a general summary of what are people doing when it comes to the clinical trials about, in this case, I think it was about memory, right? So what are we trying to do here? Maybe, yeah, let's go down a little bit. We have like, yeah, I'll show you. So we represented here the nodes of the graph. We can get questions if you want about this, but what we try to do here is we try to inform researchers about what do you need to know if you're doing research about these types of diseases. We also show like the information here. You have some references to clinicaltrials.gov. The idea here is you need to know how's research around you. You can use our tool. This saves potentially lots of money and time for researchers. This is critical to people who could have, well, important diseases. And especially, it's also very important for companies that need to investigate how to better spend their money. So thanks a lot.
Hi there. So congratulations for the demo and the work done. Can you hear me? Yes? So I have a question about the knowledge graph, because just to know if it was created beforehand or is something that you were also creating during this period. So can you just elaborate a bit more about that part?
So what we did, we used MedGen, which is a big data set that has the relations of the type. Alzheimer's is a subtype of diseases that are mental disorders, for example. We took those types of relations and we built a knowledge graph ourselves. We literally took all of those relations and we built triples that we put in a storage ourselves. So that thing is built by yourselves. Like there's nothing that was already there. I don't know if that answers the question.
Yeah, indeed. Thank you. Thank you again.
Hi again, very interesting concept. I have a lot of experience in this domain as well. I'm kind of curious too. So are you using some sort of k-means clustering or with the data set to define the associations or the correlations?
Maybe I can also answer that part. So we don't use k-means clustering because this thing is actually stronger. What this thing tells you, so you have different embeddings at first. They are randomly initialized. But what you do is you make them, like you bring them closer using a cost function. So you don't need to do k-means clustering or anything like that. You just need to train your model for some epochs, and magically you will be able to predict what's related, what's close by, just by looking at the embeddings that the model generates. No need for anything like that.
Okay, interesting.
Thank you.